Hello students, hello world, Dr. K here coming at you with a quick video. I want to show you the algorithm for the parity situation on the void cube. Wait, the void cube? What is the void cube? The void cube is one of our favorite cubes. It's a cube where the centers have been removed. We can simulate a void cube with a cube where we remove the centers. Again, I tell students if you lose a center, don't, or lose a piece or break a Rubik's cube, bring it back. We can always salvage it, repurpose it. So very quickly, you solve it just like a regular cube. Sometimes you get a situation where there are two adjacent edges that need to be swapped. So this is the situation. These two Rubik's cubes are identical. This is the commercial Rubik's cube, the void cube. You see how it says the name void? And this one we just simulated it. This one actually turns better. First of all, I just want you to understand, look at the beautiful symmetry of this algorithm. People say Rubik's Cube's algorithm, they're just memorization. No such thing. Dr. K says, look at the beauty of this algorithm. It's like music, it's like a symphony. 1, 2, 3, 4, 4 lines of code. Look at the pattern. Do you notice the pattern? Pattern with the columns. The first column. The pattern with the third column. Look at the pattern with the first row. Look how the second row and the fourth row are the same. Look at this missing link right here, the block or the pause. This is just a visual representation of the algorithm. Okay, let's do the algorithm. We hold the void cube so that the two edges that we need to swap are to the right and to the back. And then the algorithm is so beautiful. Look, middle slice up. We go over, middle slice, that we call that M prime. We go over, that's the first row. We do the M prime, U prime, M prime, U prime. And now we're down to the third row. Look, M prime, U, that's a W there, that's like two U's. And then finally M prime, U prime, M prime, U prime, and the cube is solved. So students then ask, well, Dr. K, what if we do this algorithm on a regular Rubik's Cube? What would happen? And I say the best thing to do is just to try it. Let's try it. So we'll hold it, we'll swap these two edges, and we'll see, does it do anything else in the cube? It probably does something to the cube where it doesn't matter on the void cube. So let's see. Let's go ahead and do it. M prime, U, M prime, U, M prime, U prime, M prime, U prime, M prime, U, 2, M prime, U prime, M prime, U prime. Look what happened. It swapped these two edges as we predicted, as the algorithm does, but then the centers moved this way. Look, the white center moved here, the red center moved where? Down here. The yellow center moved where? Did you say back to the back? That is right. So then how do we fix this? Well, let's do the algorithm one more time. Restore these. Circle the centers one more time. M prime U, M prime U, M prime U prime, M prime U prime, M prime U 2, M prime U prime, M prime U prime. Oh, okay, that's restored. But it looks like we have to do the algorithm how many times? Did you say 2 times? That is right. The first time, these edges are going to swap. The centers are going to move 90 degrees. Then we do it the second time. It's going to get swapped again in the right place, and the centers will be in the right place. So let's do that. M prime U, M prime U, M prime U prime, M prime U prime, M prime U 2, M prime U prime, M prime U prime. Okay, looks like we just need to do the algorithm just one more time. Just one more time. Looks like we need to do the algorithm just one more time. This time around, these two are going to get swapped. Everything else will stay the same except for the centers. They're going to move. The centers are going to circle this way towards us. The red is going to go to the red. The yellow is going to go to the yellow where it belongs. The orange center is going to go to the orange center, and then the white center is going to go back. And the cube will be solved. That's my theory. Let's go. M prime U, M prime U, M prime U prime, M prime U prime, M prime U 2, N prime, U prime, N prime, U prime, and the cube is solved. It's one of our favorite algorithms. I just love algorithms that look like this, where you can see a visual representation of the algorithm, and you see it's like lines of code, lines of symmetry. You see patterns with the columns, patterns with the rows. Again, and it's so beautiful. My job is to make you a math genius. I have the best job in the world. I have the best students in the world, and keep cubing. Proud of you.